The idea behind understanding the infrastructure ladder of an organization is very simple. We are more interested here on seeing the relationships between different kinds of systems. See, whereas architecture told us the high-level view of how should I deploy my solution, whereas here I am concentrating only on information technology. There are other things there which we'll discuss later. Again, I have improved upon the idea of the authors. I think the author's idea are at best incomplete. They have given, but they have not completed it. I have improved upon their idea and I have given my own IT infrastructure ladder. Of course, at the bottom of the pyramid are hardware. That is, when I say hardware, I am referring to, as I said, computers, networks, storage devices, and all things. Servers, desktop machines. What kind of hardware infrastructure is required? That should be clear. Right? Above that is, I am not calling it software, I am calling it software services. What kind of software service should the system provide? Let me elaborate. For example, say, one of the data service, the software service identified will be data management. That is, the main idea behind going for this solution is that there is a lot of data scattered around the organization. So, what this information system should do is collect data from this different source, put that in a central place and make it accessible anywhere to any legitimate users. So data management is the identified software service which we should provide. Nobody will say, give me a program in Java. What I am trying to say is try to differentiate between technology and language and the service which should be provided. Select the technology and language based on the need. Don't select the language first and say I will implement the solution using this one. That's the wrong idea. Identify the business problem. Then say this is the service which I will provide through some technology. That does not matter. Right? So there is hardware infrastructure over which we will deploy a service, a software service. In between, doing this services are people. We will elaborate on who these people are. There are people. Ideally the designers, the separate information department will be there. We will discuss that. Now above this are two information systems which are critical. Foundational information systems is the right word for them. It's my point. Two information systems. One information system which is called as transaction processing system and the other which is called as ERP, enterprise resource planning. See, transaction processing systems are those information systems which tackle an entire transaction. Transaction, I hope you are very clear. What is transaction? In computing terms, transaction is this activity which is said to be complete only if all the small activities which constitute it is individually successful. Any one action fails, the transaction is a failure. For example, say taking a bank from an ATM. There are a lot many activities which should happen. You should insert, the card reader should work properly, then the authentication should happen, then you type your identification number, that should be verified, it should be connected to the server. There are various things, right? Any one fails, transaction fails. If every small activity is successful, transaction is successful. Transaction processing systems are those systems which capture these atomic activities throughout its lifetime. That is called transaction processing system. ERP, enterprise resource planning systems, are those which take care about every functional unit in an organization. So these two information systems are at the lower part of the pyramid. Above this, we build host of information systems. Host of information. Depending on what you need. Recall from our previous discussions that any modern business organization will have 4 to 5 functional units. Finance, HR, production, sales. Right? We'll have different units. Each unit may have their own information system. For example, HR people will have one information system for payroll generation, one information system for managing the employees, their leave and promotion things and issues like that. Sales will have their own information system. They will all have their own functional information systems. Right? These are marketing information systems, sales information systems, HR information systems, production-based information systems, the scheduling, machine scheduling, human scheduling, issues like that, process control. So every department may have their own information system. Okay, all these things are tied together by ERP. Please understand the meaning of writing it like this. They are all tied together by ERP and transaction processing systems. Now, using all this, we have to build 3 classes of information systems which we are interested in. The 3 classes of information system we have told how they evolve. We said they evolve because of a business need. Because every business organization, the leadership ladder can be divided into 3 parts. The lowest level management, the mid-level management and the senior level management. The kind of information requests from their side are different. Therefore, we need 3 different kinds of information system which will be built above this. Using the data passed by all these information systems, we build 3 different types of information systems. One is what is called as MIS, the Management Information System, catering to the needs of day-to-day managers. What are the number of sales which has happened in this store today? That means I have to collect the sales data of all the stores provided by this and give the information. That is MIS. The next level of information systems are called as DSS, Decision Support Systems. Okay, now I know what is the sales of this store today. Please tell me what is the number of sales which happened in past 3 years, project it to me. And based on that, can you predict the sales of next 6 months? So that I will tell the production to keep their inventory as low as possible. That is middle level decision. So this data should be summarized, aggregated, plotted, and then you have to do the prediction of next data is the job of decision support systems. Fine. Above that is a more complex information system which we call it expert systems. Fine. I know the number of sales, MIS has told me. I know the number of predicted sales in next 6 months, DSS has told me, but the CEO is not satisfied with this. He wants to know what will be the impact of various other factors. For example, what is that my competitors are doing? What will be the policies of the next government which will be in the place after 6 months? Will there be earthquake after 6 months? Will the world come to an end in next 6 months? I want to know all that. To take a much more complex decision. What I am hinting towards is, till decision support systems, the data, the idea of data is still digital data, which is generated in some form within the organization. But expert systems take data not only in digital form but in other form. For example, what my competitors are doing, that knowledge comes from newspapers. Right? The newspaper, my competitor may say that we are planning a new plant in this city in next 3 months. That is not in a clean form, that is not in digital form. Right? Or maybe from inner circles of politics, I know what will be happening in politics in next 6 months. That will not be in traditional data form. That knowledge can be captured in any way. Now my expert system should integrate all those complex ideas, merge it with the kind of data I have, and then tell me what to do. That is expert system. So this is what we call as IT infrastructure ladder. This completes in a sense the basic diagnostic toolkit, as I want to call it. Anything from now, you like a doctor opens up that famous kit. I have never seen doctors carrying it, but in movies. In movies they seem to carry that kit, but in real world I have never seen doctors carrying that kit. Just like a doctor carrying a kit and opening it and having many things, or a mechanic having his toolkit, with which he can do anything. This is your basic toolkit. This should be in your mind. Whenever we are discussing something, you should start asking. Right? Is this a system? Is there an input component? Is there this component? How does it work? Well, what are these? Can we draw this? Can we understand it like this? Where is the lacuna in the system? Where can we add something? All this should come to you instantly. The only way that will come to you instantly is by practicing more. There is no point writing all this thing in a book and keeping it close. Right? Anything which you see, a new system which you see, the moment you are able to recognize all this problem, you will be a winner initially. Later we will see what. Right? Are we clear? We will start discussing case number 1.1 in